What's up? Okay. Because I will be recording this so we can share it with the other kids that can't make it on here, so they can look at it later.
Okay.
So just so you know. So what we're doing is the hydrogen peroxide lab. Let me just show you the setup. Ta-da!
Heck yeah.
Yeah. So we have, we've used the pressure sensors before. So that's on here. I have the solutions already made here in the test tubes. And this is supposed to be at 30 degrees. This water over here is probably cooled off, but I also have water baths over here at different temperatures warming up, so we can add a little bit when we need to get that to the right temperature. So, but basically, I'm going to use Logger Pro to collect all the data, and then I can share that with you guys, and you can watch me go through the lab, which is probably super lame. But it doesn't look like we'll be back here, you know, anytime soon. So we can keep plugging away at stuff. Oh, Paige is showing up. Cool. So how you guys doing?
Good.
Yeah. Relatively good?
Yeah.
Yeah.
I can't hear anyone else. Is that supposed to happen?
I don't know if Paige is muted or not. She might just be listening in. So, which is fine.
Because I can't see anybody else. I can only see my avatar and you, and I can't hear anyone else besides you. And I was wondering if that was normal.
I think it is.
Oh, okay, cool.
As I know that Jordan thumbed up over here. I know that you have to say you're going to share your microphone and camera in order to actually show up. So. All right, I'm going to just walk you through what is going on the Logger Pro so you can see the setup, if this shows up on here. Hopefully you can.
Wow.
So we're going to collect the first reaction. You can see that the water bath here in red is the one that we're currently going to react in, and then the second temperature is the one that's supposed to be at 30 degrees for the, I think that's the last one, the last reaction. And our pressure right now, that's just atmospheric pressure because I'm not connected to anything right now. So I don't know if I'll be able to do all this at the same time, but we'll try to do all this at the same time. I'm just going to start collecting right now, and I'll let it do that in the background. And I want you to see how you have to add this stuff. So, okay, we're going to do it in this test tube right here. And this is the hydrogen peroxide. Then we're going to take the potassium iodide solution. And you got to add it and shake it. Put it in there. Pop the top on it really tight so it doesn't pop out. And the reaction will start. So you can see it turns a yellow color. And it should be making bubbles. Hopefully it's making bubbles. Yeah, it's making bubbles. And let's just take a quick look at the pressure. Looks like I might have messed it up actually. Hold on. Yeah, I put the cover on too tight. But this part of the data right here should be pretty good. We should be seeing an increase in pressure. Obviously, there's a big jump where I shoved the stopper on like a crazy person. But we're just looking for getting kind of idea what the slope is of this over time as the reaction is going along. All right, and then we are getting some bigger bubbles in there now. And the pressure is coming up, so that's good. We'll go back to look at Logger Pro. Yeah, so the pressure's coming up nicely now. This is supposed to run for 3 minutes, like the lab says. What we sometimes have problems with is it will gain too much pressure and the whole top will pop off of it. So I'm hoping that doesn't happen.
That would be funny.
Probably hit me right in the face the way I'm standing over it right now.
Oh no. Was this supposed to be our next lab?
Yeah, this is the hydrogen peroxide lab.
Oh, okay.
Yeah, we were supposed to do this Monday, which I don't know if you noticed didn't happen. All right, so that's done.
Is this supposed to be a lab write-up?
Yeah, we'll do a lab write-up based on the data we're collecting together.
Okay.
And yeah, just scrolling through the, so we got up to 110.39. You can see the pressure is still going up, but we really only needed to time this for 3 minutes. So that's pretty good. So I'm gonna store that run. So we're ready to do trial 2. All right, so for trial 2, we are supposed to do the same thing, except this time we're going to use a mixture for the Ki that's only 50% as strong. So it's the molarity of it is 0.5 molarity because before it was, 0.25 because before it was 0.5 molarity. So we're going to see how that affects the reaction rate of hydrogen peroxide. So let me pop the top off this. Pour it out. You can see it's still fuzzing around. That looks nice and gross. Rinse that out with tap water, and then I'm going to rinse it with a little bit of distilled. Contamination out of there, hopefully. I wish you guys were doing this lab. All right, so this is the hydrogen peroxide. We have 4 milliliters of that, 3% hydrogen peroxide. And then, oh wait, I gotta get Logger Pro going. So trust that I'm doing that in the background, okay? All right, so I have Logger Pro collecting data. Yep, okay. And now I'm gonna take this is the catalyst, the 50-50 mix, and I'm gonna pour that in there. Give it a little shaky, get it back in there, and get the cap on there nice and snug. All right, so the reaction, I think it started. Let's look at the data once I find Logger Pro again. There you go. All right, so yeah, I guess there's no real good way to get rid of me putting on the cap like a crazy person, because you can see putting the cap on raise the pressure like crazy. So this is going to be the useful data here again.
Is it not supposed to shoot up like that?
Well, when I put the cover on it, I accidentally pressurize it, and I can't really think of a good way to do that without, because I got to put the cap on. Maybe if I put the sensor in afterwards, it would help. Actually, I might try that the next time, but we're looking for this to go up from there. and it's going much slower than the other one, which matches because it has half the strength. The catalyst has half the strength. So let me just show you what I'm seeing in the test tube, if I can get you down there. It's got bubbles and stuff forming in there, but they're much smaller, they look like. I don't know, they're about the same size. There's probably just less of them. So, does anybody know what those bubbles are with hydrogen peroxide?
I don't know.
Anybody remember what hydrogen peroxide?
Oh, H2O2?
Yeah, hydrogen peroxide is H2O2. Yep. But what does it break apart to?
Oh, H2O and oxygen.
Yep. And
So those bubbles, it's just oxygen?
right. Yeah, good. The bubbles are just oxygen. Thank you, scary looking Rachel.
You're so welcome.
All right, so yeah, we're almost at the 3 minutes, but we can definitely see the reaction rate is a lot less compared to our first trial. So yeah, it's done now. And I'm noticing that the temperature of temperature 2 is getting kind of low. So I'm going to add more water to that, some warm water to boost that back up. So, because that's our last trial, is trial 5. So, all right, let's, we'll store that run.
What's temperature 1?
Temperature 1 is the reaction we're doing right now.
Okay.
Yeah. All right, so we stored that run. Let's come back and look at the setup. So temperature 1 is this temperature probe that's in this container, and temperature 2 is this temperature probe, which is in this container with the last trial. So, and that one's right around 30 right now. So we'll just have to make note of what temperature it actually is. All right, so dump that out. Rinse it out with water. Rinse it out with distilled. All clean. All right, so that was 2. So now we have to do 3. What's different about 3? Oh, 3 has, instead of 1% hydrogen peroxide, I diluted it to 1.3% hydrogen peroxide, so it's half the strength. But we're going to use the full strength of the potassium iodate solution. So, boy, that looked backwards on my view. All right, so I'm gonna, did it look weird to you?
No.
Okay. All right, so I'm going to pour the hydrogen peroxide in here first. Oh, let me start Lager Pro. All right, so I'm going to put the cap on in a different way this time, so I hopefully don't get that big spike. I'm actually going to take the stopper off of it and add my Ki, the potassium iodide, 1 milliliter of that. Shake it up. It's already yellow. Put that in there. Make sure that cap's on there tight. And pressure sensor. Okay. Let's take a look at Lager Pro and see what's going on there. I started it, right? Oh, yeah. Okay, wow, we're doing shades of blue today. Yeah, there was no initial spike. So it's not going to look like the other ones. Come on, go up, go up. Did I not seal it raw?
There it goes.
There it goes. All right, good. Yeah, not too much increase though. Little jumps here and there. Just little jumps. Oh, I wish I had lab music playing. The building is so quiet, it's creepy.
Is it just teachers?
Yeah, but it's only like me. I guess Otterson's here somewhere too. I saw him in the hallway, but he was keeping his distance.
Yeah. So it's basically just science teachers at the building because they have to do like labs and stuff?
Yeah. Well, I think there's going to be more later because they have to make some materials to send home to students. So
Yeah.
they're going to use the buses, and parents are going to come in to get materials. So yeah.
Fun.
Good thing I gave you guys everything, right?
Yeah. Oh, you lost the bet.
Yeah, I lost the bet big time. Yeah, I was pretty sad about that. I can't believe Mr. Tui was right. That's the crazy thing. Oh, jeez. All right, so we're almost out of time for that one. Not much of an increase there. It's going to be interesting because we got to go from like beginning to end to see, what those increases are. So we'll pull data for that. I could probably send this file to you guys too if you have, your Logger Pro and stuff on there. So I'm going to be smart this time and store that run. I think it was better putting the cap on the way we did it that time compared to last time. So let me pull the top off of that. That was number, uh-oh. Oh no, now I'm ultimately confused. 3 trials, right? Yeah, so all I have left is the warm one now. Okay. So, all right, I'm gonna do things backwards for this one though. So we're gonna do the KI first. I have to transfer it over to the is at 31. It's a little high, but it will work. I kind of want to warm the KI up a little bit though, so the temperature might drop a little bit. And but the start line. So the stopper, I'm going to use the same technique. And we're at 31.2 degrees. Pressure's ready to go. So I'm going to pour this in there. Put the stopper on. Where did I put it? Oh, there it is. And, I got to shake it. And color change, excellent. Shake it. Cap, water. And under pressure. All right, let's look at what that looks like as a graph. All shades of blue. Crazy. All right, temperature's at 31. Now we just have to let it wait for 3 minutes and hope the top doesn't bust off of it. So in this lab, one of the things that you had to do for pre-lab was calculate the concentration of the hydrogen peroxide mixture. Because hydrogen peroxide's weird. It's measured in, percent, and it's actually a mass percentage thing. And we didn't really talk about this when we did our solutions earlier. We didn't talk about we talked about mass fraction, but not mass percentage. Mass percentage is kind of a weird one because it's got to do with the mass of the solute in grams and the volume of the solution in milliliters. So for 3% hydrogen peroxide, you know, it's saying that you have 1,000 milliliters and like, you know, 30 grams of it is hydrogen peroxide. So I'll show you how to set up that calculation here in a second once we get the rest of this data. The graphs I'd like to share with you so you can use them, but we'll look at them together a little bit just so you can see, you know, what the minimum and maximum pressures were, so you can use that to kind of do the calculations. And then we're going to calculate the rate constant from that. So, oops, the top popped off. Gosh dang it, I missed it. So that data is done. We'll just have to get the top before it died. All right, so I'm gonna auto scale that. That didn't change much, and then look at the statistics for the those runs for all of them. There's 4 trials, and the first ones I kind of goofed up on, so I'm gonna pull. These are all together, aren't they? Which one is this one? Which one is this one? All right, I'll put that there. And which one is this one? Okay, that one's number something. Which one is this one? All right, yeah, this one I want it to really start reading up here. And then, oh my gosh, this one up there, okay. All right, so run 1. The lowest pressure was 106.6 and maximum was 110.4. Run 2, the starting one, or the minimum, was 106.1 and the maximum was 107.5. Run 3, oh wait, yeah, run 3 was minimum 103.3 and maximum was 3.8. And the last one was minimum 105, nope, 103.3, sorry, and maximum was 108.6. Boy, that's hard to read. So those are, we can get slope from that, is the main thing we want. And there are times listed for that, so you can do like rise over run, because it's a reaction, you know, it's over seconds. It's like change in molarity over seconds. So, so we can get some data from that. All right, so let me talk a little bit about how mass percentage works. Look, I wrote it out. It looked backwards for me, but hopefully it's not for you. So the 3% solution, we are using 4 milliliters of the hydrogen peroxide, and we're looking for the amount of moles, because we can, what we really need to know is molarity. And mass percentage, like I said, is the mass of your solute over the volume of your solution in milliliters. So I'm just solving for, I got to solve for the numerator. So knowing that, if you take the 3% and divide it by 100, it's 0.03, and you multiply by 4 milliliters, and you get 0.12 grams of hydrogen peroxide, H2O2. And wait, the lights just went out here. And the formula weight for that is 34 grams per mole. So we can divide that to get a 0.03529 moles of hydrogen peroxide in 4 milliliters. So molarity, as you know, is moles over liters. So that's our moles, and our volume I had to convert that to liters, was 0.004. And then that gives us a molarity of 0.88, what is that, 23? And then we diluted it to 5 milliliters. When you add the Ki to it, you have to add a milliliter, so it dilutes it to 5 milliliters, and that means it's 0.7 something 7058. So that's when you've mixed it all together. I don't know if they lost power in here or what, but it's really dark now. Am I not moving enough? This school is creepy without you guys in it. Oh my gosh. So what I'd like everybody to be able to do with that, and I'm sure there's going to be questions that I haven't even thought of yet, but it would be good if we could use the information that I'm going to share and the measurements that we have to kind of do this lab on our own. And I'll put this video up on my super successful YouTube channel.
I messaged because we have like a Snapchat group chat, and I messaged the group chat and said Roy's YouTube channel is the only thing that's gonna get me through Coronacation.
Coronacation? Oh my gosh.
That's what everyone's calling it.
I hadn't heard that yet. That's awesome. Yeah. Well, I'll try not to burn the whole school down, although it might not matter. I don't know. But anyway, so I'll give you some time to finish, writing this lab up, because I know there'll be questions and stuff like that. And we can do another one of these if people, want to come back and ask questions about anything. But I would like to eventually get to taking a quiz on this unit so we can kind of move on, because who knows how long Coronacation is going to take. As of now, it's still next week that we're planning on not being here, but the writing's kind of on the wall for it to be longer than that. So, but definitely miss you guys, and I'm gonna end the lab now. But it was really good to at least see Rachel's weird avatar, and that other people are in the background paying attention. Thanks, Jordan. Jordan keeps plugging with a thumbs up. Oh, Paige, is that a clap? I don't know what that is.
How do you do
that? But anyway, so I look forward to seeing you guys sometime in the future. And we might get an AP Chem group together if, we're not all sick. So, but
Heck yeah.
Heck yeah. All right. I'll see you guys around. Bye.
Bye.
I gotta quit.